All right, we started section 2.1 last time. Well, technically we continued it last time in class from a previous video you'd watched. And we had talked about DeMorgan's laws, which create logically equivalent statements using a negation patterning. And we had done one as an example with a truth table showing that DeMorgan's laws really work. Right, I did a generic truth table with two statements. One of them I used DeMorgan's laws, the other one I used it sort of as is, and sure enough at the end they have the same true-false statements. So what you'll remember about DeMorgan's laws is that they tell us how to negate a quantity of something by distributing negations through a set of groupings, parentheses in this case. And what happens is that we end up, over here is the particular rules, with distributing it to all three pieces. Both the statements changed from either a positively worded or negatively worded statement to the opposite, and the ands and ors change places, okay? So we have an example here of DeMorgan's laws, and it's actually an actual statement, okay? So it says, "It is not sunny and I will go for a walk." So anytime we're talking about DeMorgan's laws, we're talking about a compound statement. So it will have two individual pieces of a statement, and it will have a connective in between. Okay, there's three pieces. And to use DeMorgan's laws, I have to negate all three of those pieces. So we'll start at the beginning. The first part says, "It is not sunny." So what's the negation of "it is not sunny"? It is sunny. Right? And then we have to negate the connector, right? What's connecting them right now is the word "and." So if I change that, it will change to "or." And then we negate the second piece as well that says, "I will go for a walk." And what's the negation of that piece? Yeah, I will not go for a walk. Okay, so actually applying DeMorgan's laws to language hits three different pieces. And, anytime I ask a question about this on a test or on a final or anything, undoubtedly it's the middle part that people forget. They forget to change ands to ors and ors to ands. They're usually pretty good at changing the individual statements, but they forget about the connective. So circle it, star it, something so that you don't forget about the connective if I ask a similar question for you later on, okay? All right, I had mentioned last time that there are three different types of compound statements. One uses the word "and" that one is a conjunction. One of them uses the word "or," and that's a disjunction. And I said there was one more, and we'd talk about it later, and that third one is an if-then statement. And an if-then statement is actually called a conditional. So conditional statements are expressed in the form if P, then Q. Or you will sometimes hear them phrased, P implies Q. And they're written with an arrow between. So this would be P implies Q, or if P, then Q. The part at the beginning, the if part, is called the hypothesis. The part that comes at the end, the then part, is the conclusion. Now, just like when we talked about conjunctions and disjunctions, the first thing we did is we created sort of after I gave you some substance in terms of symbols, is that we created a truth table to talk about when these statements are true and false, right? When we combine the pieces together, when are they true, when are they false? So that's what we're going to do next here. So go ahead and create a truth table with 3 columns. The first column is P, the second column is Q, and the third one is the implication or conditional P implies Q. And just to make sure everybody's remembering what to do from last time, I want to give you just 30 seconds or whatever and fill in P and fill in Q from what you remember we did last time. Okay, so somebody tell me what you have in the P column. Good. Good. True, true, false, false. And then someone else tell me what's in your Q column. Excellent. True, false, true, false. So no matter what kinds of statements follow, the P and the Q columns always stay the same. Now, I'm first just going to fill in what is in this column, and then we'll talk about why it makes sense. Sound good? Okay, and it's a little bit different than how I did the other ones, but this first one is true. The second one is false. And then the last two are true. I'm going to do an example that I tend to use for this, but some people still get confused a little bit with it because it just feels a little bit funny. And then we'll talk about how you can think about this in a different way too if you don't like this. So I'm going to say, if I am a mom, then I am a woman. Okay, everybody good with that? Okay. So on the first piece right here, both of the individual statements are true, right? I'm a mom, I'm a woman, and we'd say that this statement written as here would be a true statement, correct? Absolutely. No problem with that, yeah? The second statement ends up being very interesting. So someone comes in and says, I'm a mom, and they say, I'm not a woman, and you say, well, that's a little bit funny, right? The language doesn't support that particular string of statements together, the conditional. So that's a false conditional statement then. The part that confuses, those parts are usually pretty good. Everybody's like, yeah, I got those, no problem. It's the next two parts that are really funky. The next two parts start out false, which means that the person making the statement says they're not a mom. And the problem is that that means they could still be a woman. In fact, most of you are in that scenario in this classroom, right? I don't know, do we have anybody in here who has children? Not in this classroom? I do in my other class, okay? So you're those people. So if you came in and you say, I'm not a mom and I'm a woman, that's still true, correct? It's still true. But somebody also could come in and then they could say, I am not a mom and I am not a woman, and that could also be true. Agreed? Yeah. If any of you have boyfriends, hopefully that's them, right? They're neither of those things, and you're good with that, right? Absolutely. So the reality is that the way that I think that's maybe the easiest to think about it is that no matter what happens, if a statement starts out false, the hypothesis, then there's the assumption or the underlying assumption that you're going to believe that the person talking to you is telling you the truth. Right? Innocent until proven guilty kind of stuff, right? Unless I have a reason to doubt that my kids are lying, I'm going to hopefully believe that they're telling me the truth. So if a statement starts out false, if the hypothesis is false, then the conditional is still a true statement, always. All right? I think I have an example. Yeah, that's what I thought I had here. We're going to do an example with some symbols, and then we're going to flip it around and start with the symbols and do some language. This one actually has some statements you may or may not recognize. This says to let P be the statement, you build it, and Q be the statement, they will come. Does anybody know what that's from? Brooklyn says she does. What's it from, Brooklyn?
Well, it's some baseball movie.
It is a baseball movie. Does anybody know what it is?
Knocked it out. I don't like it.
It's called Field of Dreams. It's really old. It was old when I was young. Field of Dreams, and Kevin Costner's in it, I think is right. Anyway, so yeah, if you build it, they'll come. That's actually the statement in the movie. So what we're going to do with the language here, though, is we're just going to write the symbols that the language represents. And I'd particularly like to do this here because there's some really funny things that happen with conditionals that we don't have to worry about with conjunctions and disjunctions. And it has to do with the placement of the word if. So wherever your if starts, what comes immediately after that is actually the hypothesis of your statement. So even though this if is at the end of the statement, it's really my hypothesis. So if you build it is my hypothesis, and what symbol is if you build it, or is you build it? It's P. So this is a P arrow. And then the conclusion happens to be listed at the front of this statement. This is one of those weird English things we do all the time. We switch words around, and sometimes it matters what the order in, and sometimes it doesn't. So here, the if is still associated with the you build it. They will come, though, is the conclusion. So this is still P implies Q. In other words, this is the exact same statement as saying if you build it, then they will come. So read the two statements yourself. That is what that statement means, right? They will come if you build it. It's the same statement as if you build it, they will come. Now, on part B, it's a little different because the if starts at the beginning, right? So we kind of like that a little bit better. It feels a little more natural, especially when we're changing it into symbols. So this is our hypothesis. It says you do not build it. What symbols is that referring to? Yeah, Kira's right. Yeah, she's put like she drew it in the air for me. Yeah, it's a tilde. It's called a tilde. And it's still P, though, right? Because it's still talking about building, and that's the P component of my two statements. And it's still an if-then statement, so it still has an arrow. And it says, then they will not come. So what is then they will not come going to be? Yeah, it's a negation again, and this time it's the negation of Q. On your homework or group work, I think it's in the group work, just so you know, if you see arrows that have arrows on both ends, there's somewhere in the homework or group work that you do. This statement actually says if and only if. That's what that means. And it means it goes both ways. It means you can say if and you can read it this way, or you can say if and you can read it the other direction. That's what it's called, a biconditional. It works both directions. So when you see that, you'll know it means if and only if. Okay? Notice it doesn't say that they won't come. The actual original statement says, if you build it, they will come. That's what I've written in there on part A. But it doesn't say that for sure that if you don't build it, then they won't come. That's not necessarily the same statement. And in fact, we're going to get to that one in a minute. So we're going to go the other direction now. So we have some different statements this time. P is the statement, God loves me, and Q is the statement, I'm a sinner. And we're going to write the words out for the symbols that are shown here. So we start with the symbol P, and the symbol P is the statement what? God loves me. What symbol, what word goes with the following symbol after that? It's and. And remember, one of the ways that I told you could remember that is it kind of looks like half of an N, right? The first half of the N. All right, God loves me, and then what is Q? I am a sinner. Okay, so that's the rewritten form with the language for those symbols. Okay, we're going to do the same thing on part B. Part P has a tilde P at the beginning, so what is tilde P going to be? What is it? Not, okay, it means not, you're right. Not what? The not about the God statement. I need a sentence. Can we get a sentence? God does not love me. That's exactly what that statement, that symbol means in that location. It's the negation of God loves me, which is God does not love me. Okay? That's what the symbol says. It's not a true statement, right? That's false. God loves you. Please don't misunderstand. Don't you go leaving here and telling you somebody that your teacher said God didn't love you. That's not what happened, okay? All right. God does not love me is this statement on the screen. What does that arrow mean? It's an if-then statement, right? So in front of God does not love me, I'm going to write the word if. I'm going to run out of space, so I'm going to shift it down a little bit. And after God does not love me, I'm going to write the word then. Okay, so that's the if-then connective, right? That arrow. And then what's Q? I'm a sinner. Okay, just rewriting language. And you'll have some practice on that in your homework and in your group work as well, where you're going both directions, starting with symbols, writing words, starting with words, and writing symbols. All right, there's one more piece of information in this section that's kind of a fun one. And this actually talks about some language that you've probably seen used before, and it's conditionals language. So we're first just going to write down the symbols, and then we're going to do an example, okay? So if your original statement with a conditional is P arrow Q, okay? P implies Q. So that's where we start. And the next three are built upon that statement. So if we talk about the converse of the statement, what we do is we switch the P and the Q around. So this says Q arrow P. So we switch the order of the hypothesis and the conclusion. That's the converse. The inverse actually keeps the order the same, but it negates both pieces. So the order was P and then Q. So we negate both pieces with the arrow between. And then the last one, which is the contrapositive, switches both things. So it switches the order and it negates. So this is tilde Q implies tilde P. And when you get to your group work, you will explore which of these four statements are actually equivalent to one another. You'll do it with those logically equivalent tables, I believe, that we did like on the last lesson at the very end, where you just did some truth tables and you looked at those final columns. So, but the reality is they're not all four exactly the same statement. Okay? And I want to show you a video real quick, if I can find it, to show you how in the world these are not all logically equivalent to one another. All right, so Larry and Bob do not quite have the right idea, or at least Larry doesn't, about conditionals and them working in which direction and so forth. So we're going to do the example number 8, which is to create the converse, the inverse, and the contrapositive for a statement. So this is the original statement. If I'm a monkey, then I have a tail. And that statement is actually what Larry was trying probably to say that the zoo lady said, right? If it's a monkey, it has a tail. So this is our original statement. And we're going to create the other three that go with it. The converse, inverse, and contrapositive. So in the converse, we actually take the two statements and we reverse the order, okay? If stays at the beginning, don't go moving the if. The if's not moving, the then's not moving. It's the statements that are moving. So it still says if, and then it says if what? If I have a tail, then I am a monkey. And clearly, that's why he thought the cow was a monkey, right? He saw a tail. So that's the converse. The cow actually works in that statement, and there's a problem with that logic, right? Yeah. An inverse. Now, the inverse doesn't change the order of things. It negates them. So again, ifs and thens don't move. But the part about the monkey stays at the beginning. If I am not a monkey, then, and some of you guys have already said it, I do not have a tail. Again, that's the cow, right? It is not a monkey. It does not have a tail, and unfortunately, that didn't work, right? Because it does have a tail. And our last statement, the contrapositive, So it reverses the order, not the if-thens, the order, and it negates at the same time. So if is the beginning. So originally monkey was the beginning, so now I need the tail part at the beginning. What does it say? Does it say I do not, how did I straighten it? Okay, yeah. If I do not have a tail, then what? Then I am not a monkey. And of course, that's what that's what Bob was trying to say at the end. And then we saw he actually had a tail and it all just fell apart, right? But that's what he was trying to say at the end. Okay, and that's probably also what the zoo lady was trying to differentiate between the apes and the monkeys, right? Was in that part of the statement. So, fun stuff with silly songs.